Well, hello. Today I'm coming to you live from my very own kitchen table. So if my background looks a little crazy, that's what I got going on. Let's take a look at concept 4. Today we're going to finish up chapter 2, at least the first part of chapter 2, and finish up solving equations. We're going to look at special cases. Sometimes we have situations that are known as identities and no solutions, and these are special situations that you'll see from time to time. So let's take a look at some examples. If you look here at this first example, we have 10 minus 8a equals 2 times 5 minus 4a. So the first thing that we're going to do is distribute that 2. All right, and that's how we get down to the bottom line, or the next line, where we've got nothing changed over here, equals 10, because 2 times 5 is 10, and then 2 times negative 4a is negative 8a, so that's where that came from. And then since we have nothing to combine, we don't have any like terms, now we're going to put our variables on one side and our constants on the other side. So to move this variable term to the other side, we have to do the inverse operation. So we add 8a to both sides. But look what happens. Here, it's going to cancel, and here, it's going to cancel. It cancels out on both sides, and we're left with this last statement of 10 equals 10. Well, does 10 equal 10? Yes, of course it does. So because 10 equals 10, that's called a true statement. And if you look over here, our second section here says, if you end up with a true statement, such as 10 equals 10, like we did in our example, or it might be 0 equals 0, something that you know, well, duh, yeah, that's always going to be that way, then it is what we call all real numbers, because it doesn't matter what you plug in for x, because remember, our solution is, what can I plug in for x to make this statement true? Well, if x cancels out, then x doesn't really matter. It's always going to be true. So you could plug in any real number and end up with a true statement. So that's why our solution is all real numbers. Another way to write that is, you draw two lines right next to each other, and then you draw like an R. Okay, that symbol means all real numbers. So that's another way that you can write your solution for those. But what happens, like this example, if you do all of that work? Let's see, we've got 6m minus 5 equals 7m plus 7 minus m. So we take this 7m and negative m when we combine like terms to get our next line, 6m plus 7. Nothing changed over here. Now it's time to move our variables to the left and our constants to the right. Again, it doesn't matter which side, but that's an easy way to do it. So that's what we're going to do here. We're going to move this 6m over to the other side. We're going to do the inverse operation. Well, here that cancels. That's what I expected. That's what I wanted to happen. But it cancels over here too. Crazy. Our variable completely disappears. And we're left with this statement, negative 5 equals 7. Well, that's not true. That's never going to be true. So in this statement, it doesn't matter what you plug in for x. This equation is always going to work out to be false. It doesn't matter. There is nothing that I can plug in. So if you look up here at the top, if you end up with a false statement, something that's never going to be true, such as negative 5 equals 7 or 4 equals 8, those are not true. And there's nothing we can do to make them true. So our solution then, or what we would write, is no solution. There is nothing that we can plug in for our variable to make that statement true, because the variable completely cancels. It's irrelevant. It doesn't have any effect on the outcome. The outcome is always false. Okay? So these are the two special situations. The one that's always true, this is known as an identity. It's a good vocabulary word for you. This is known as an identity. The other one, just no solution, no problems there. So let's take a look at some examples together. So first, let's take a look at number 57. 57. All right, before we get too crazy, we're going to draw our fence as a line, and then we're going to check for distribution, which I do not have because I don't have any parentheses. Then I can combine like terms on the same side. Well, here I have a constant term and a variable term and a constant term. Here I have a variable term and a constant term. So I'm going to put together the things that are alike. These are both constant terms, so I can put them together. 1 and negative 7 is negative 6. So I'll do 3x minus 6 equals 3x minus 3. Now I want to move my variables to the left, my constants to the right. So I'm going to move this 3x, this variable term, I want it to move to the other side. And I do that with an inverse operation. So instead of positive 3x, I'm going to use negative 3x. And I'm going to do that over here too. Notice that I'm lining it up underneath the variable terms that are already there because that's what I'm moving. Now when I do that, here it's going to cancel. That's what I was expecting. That's what I wanted to happen. But look, it cancels over there too. And I'm left with this statement of negative 6 equals negative 3. That's not true. That'll never be true. So my final answer then is no solution. And another way that you can write that is with a 0 and a line through it. It means like absolutely nada. Nothing's going to work. Let's take a look at another one. 58. Before we get too crazy, draw our fences a line. Check for distribution. Nope. Then I can combine like terms on the same side. So let's see, I've got a constant, constant, variable, constant. Constant, variable, variable. All right, so I'm going to look at this side first, and I'm going to combine anything that is the same. So all of these constant terms are going to be combined. 3 plus 3 is 6, minus 3 is 3. So my x stays the same, and I have plus 3, because I had plus, plus, and then just a minus there. So I end up with positive 3 equals, let's see, what can I combine over here? I can combine this negative 5x and this positive 6x to be a positive 1x. So this becomes positive x and positive 3. I just kind of change the order a little bit there, and that's okay. As long as my signs stay attached, I'm good to go. Now, move my variables here, get my constants there. So I'm going to move things around. I'm going to move this variable by subtracting it from both sides to undo it, because that's the inverse. Here it cancels. That's what I was expecting. But over here, it cancels also. Weird. So I'm left with 3 equals 3. Well, hey, that's true. So my solution then is all real numbers, or I could just write that fancy R. Why don't you take a look at number 59 and 61? Pause the video, see if you can do 59 and 61, and come on back when you think you've got it. How did it go? You should have gotten all real numbers for 59 and no solution for 61. So if you didn't get that, pause the video again and double check your work and just make sure that you understand how that comes out. Let's do a couple more together so that you can see just some more examples of how this is going to look. Let's take a look at 63. Before I get too crazy, I'm going to draw my fences a line. Check for distribution. I've got parentheses here, and I cannot combine like terms inside the parentheses. So that means I need this number out front to distribute to get rid of my parentheses. So I'm going to take this -1 and I'm going to distribute it into my parentheses. -1 times -6 gives me positive 6m, and -1 times positive 5 gives me -5 equals 6m minus 5. Uh-oh, check it out. 6m minus 5 equals 6m minus 5. I can already tell that it doesn't matter what I plug in. These are exactly the same, and that's a good thing. So if I move my variable term using that inverse operation, if I subtract it, here it cancels, which is what I was expecting, and here it cancels. But that's okay because everything else is still the same. So that's true. And my answer here is going to be all real numbers, because it doesn't matter what I plug in for m, this statement is always going to be true. Let's take a look at number 65. All right, 65. Draw our fences a line. Check for distribution. Let's see, I've got parentheses here, so I'm going to distribute this. Notice I'm keeping my sign attached, and then I'm going to distribute this as well. Again, keeping my sign attached. So I've got 7, and then -5 times 7 is -35. -5 times -1r is positive 5r equals -2r, and then positive 7 times r gives me positive 7r, and Let's see. Positive 7 times negative 2 gives me negative 14. Cool. Now, so check for distribution, then you can combine like terms on the same side. All right, so let's see. I have a constant variable. Well, these two constants can go together. 7 minus 35 is going to give me negative 28. And over here I've got variable, constant. So my variable terms can go together. Negative 2 and positive 7 gives me positive 5r and minus 14. Now, get your variables here, put your constants there. So I'm going to move this variable term over to the other side. Uh-oh. It's going to cancel here, which is what I was trying to do. I wanted to get it away from there, move it over to the other side. But it cancels on the other side too. Crazy. So then we have negative 28 equals negative 14. Well, that's not true. That'll never be true. So my solution then is no solution. So there's no solution to that problem. Nothing will ever make it true. All right? So why don't you go ahead and finish up these last few, and that's it. We are done with chapter 2A, done with chapter 2A, done with chapter 2A. That's my little done with chapter 2A dance. Happy to share it with you. Hope you have a great night, and we'll see you in class.